Hey guys, hope you're all doing good. A lot of you had questions regarding how to set up the legend correctly when you're doing a parametric study with flow simulation. So one thing you need to do is, before you run the parametric study, first create the basic cut planes that you want. So for example, I'm just going to create a cut plane. I'm going to be using the XYZ planes, and maybe let me just select the YZ plane. And what I'm going to do is I'm going to be making a plot of the velocity. All right, and then almost immediately you can see that there is a button which says adjust minimum and maximum. So let's click on that, and you need to make sure that you set this to global maximum and minimum. All right, so now what I'm going to do is, here you can basically reset this to plot maximum and plot minimum, which would also work. Now do not type in numbers here. For example, I've seen that some students type in a value of 10 meter per second or 11 meter per second. That's not going to work, because in your challenge you're changing the Reynolds number, which means your velocity is going to increase. So in other words, you don't want to set the minimum and maximum value of velocity. If you do that, then that range might actually be too narrow for a case with high Reynolds number, and your plot is all going to appear red. Alright, so make sure that this is set to global maximum and minimum. And then what I'm going to do is, I'm going to right click and then select new parametric study. And then we are just going to click on add simulation parameter, and I'm just going to select the boundary condition, and let's just take the inlet velocity and select the velocity normal to the face. You can see that it's initially set at 10 meter per second. And what I'm going to do is I'm going to select this option range with number. So we're going to be starting at 1 meter per second, and we're going to go all the way up to be 20 meter per second, and we're going to have 3 values in between, and click OK. Alright, and then for the output parameter, I'm going to select add results, and I'm just going to select the cut plane, and then I'm going to select the cut plot and click OK. And then if we go to scenarios, we can just click on run. Alright, so looks like we have the results. So now if I click on a plot, you can see that the scale goes from 0 to 1.096 for the first one, and for the last one it goes from 0 to 21. Now this is technically the right plot. Now you can see that near the walls the velocity is lower. This happens because of the boundary layer formation. And now if you create a line probe, then you will be able to get the parabolic velocity profile. Now the other option that you can use is plot maximum and minimum. So let's set that up, click OK, and then we are going to open up our what if analysis, and we are going to go to the scenarios, and I'm just going to make sure that recalculate is enabled, and I'm going to run the cases one more time. So now in this case, if I open the results, you can see that the color variation is still more visible, but don't get fooled. If you look at the values of the legend, it goes from 16 to 21 meter per second. So what's happening is really small values are being cut so that you can actually see the variation. Alright, now for presentations this is fine, but from a technical point of view, both the plots, whether you use global maximum or plot maximum, you're going to get equivalent results, and at the end of the day you will have to use line probes to basically compare the velocities. Alright, hope that makes sense. Now the final note that I wanted to make is, when you go to the cut plot and when you're basically trying to add the legend, never add the values manually, right? So you should never put the max value and min value manually, especially if you're doing a parametric study, and I hope the reason for that is clear. Alright, with that I would like to conclude this help video. Thanks for watching. Bye.